All right, I want to show you how to solve some a little bit more challenging questions involving special right triangles. So I'm going to go over to the next page and you can see a little bit more difficult problems, but it's still using those same concepts. So let's start on the left side. So if I want to solve for x in this picture, what I would do is find out the value of the side opposite from the 30 degrees. So for example, what is my starting point? What would this be considered, right? I know that the side opposite from the 60 degrees is 18, and I also know that 18 has to be whatever the 30 degree opposite from the 30 degree side is times the square root of 3. So what would I do to solve for my question mark? I would divide by the square root of 3 on both sides. Now, I don't want to leave my denominator with a radical sign, so instead what we're going to do is multiply by the square. We're going to multiply by 1 in a creative way. We're going to multiply by the square root of 3 in the numerator and in the denominator. And that has a value of 1, right? Because 5 over 5 equals 1, negative 8 over negative 8 equals 1. Square root of 3 over the square root of 3 has a value of 1. So I'm not changing the amount of 18 over square root 3. I'm just simplifying it to get rid of the denominator with a radical sign. When I multiply across, I have 18 times the square root of 3. In my denominator, the square root of 3 times the square root of 3 becomes 3. Because when I square a square root, that's undoing itself. I can further simplify because 18 is divisible by 3. That gives me 6. So if this side is 6 times the square root of 3, and that's the side that's opposite from my 30 degree angle, I know that my hypotenuse, right? So my hypotenuse right here, this side, is going to be twice the amount as the side that's opposite from my square root of 3, right? So I'm multiplying 2 times what I got to be my question mark. Let me do that in purple so you can see it a little bit better. So 2 times my question mark, and I'm using a question mark. You could use a variable here. I'm just using a question mark because sometimes it's easier since we already are solving for x. So 2 times, what did we get across from the 30 degree angle? 6 times the square root of 3. So when I multiply, that's going to give me 12 times the square root of 3. I didn't need to parentheses just then, so I'm just going to remove those parentheses right now. We could leave it like this, or you could plug it into your calculator and get a decimal value. If you were to plug that in, it would be around 20.78. Now let's look at this next question. So this next question requires two concepts, right? Because we're looking at a 30, 60, 90. We're also looking at a 45, 45, 90. The information that I'm given here is on my larger triangle. So let me actually break this up into two triangles. Maybe you'll be able to see it better. I have a larger triangle that is 60 degrees and then 30 degrees down here. I have a hypotenuse of 12. If my hypotenuse is 12 and I take half of that, that should give me the length of the side that's opposite from my 30 degree angle. So half of 12 is 6. So what I'm getting is this side right here is 6. Now I want to look at thinking of this entire side right here, and then making that connection with the y that I'm trying to solve for, okay? So here we have a 45, 45, 90 triangle, and I know that one side is 6. Well, on my 45, 45, 90, my legs are congruent. So that means that this distance from here to here is 6, right? Okay, now let's go back to my 30, 60, 90 right triangle that I have. How long is this entire side? Because that would match up with my yellow over here, right? So how long is that entire side? So that side is going to be 6 times the square root of 3, since it's opposite from the 60-degree angle. That means, let me put this in blue. I know we got a lot going on. This entire length right here is 6 times the square root of 3. So what I would do to solve for y, let's sort of set this up like an equation. 6 times the square root of 3 is equal to 6 plus y. So what would I do? I would subtract 6. Subtract 6. So my y value, this is going to be, well, I guess if you wanted to leave it in the most accurate form, it would be like this. But if you had to plug it into your calculator and round it, that's going to be about 4.39. Okay. I want you to be cautious here. When we're doing 6 times the square root of 3 minus 6, that does not give us the square root of 3, okay? The square root of 3 is not 4.39. Plug that into your calculator and recognize that I'm multiplying right here, 6 times the square root of 3. And then I'm going to subtract the 6, okay? I hope that was helpful, guys. What I'm going to do is I'm going to go over the 2 common special right triangles that we are working with. So we have what's called a 30, 60, 90 right triangle. Those numbers are giving me the size values of the angles that I have. So I have a 30 degree, 60 degree, and then a 90. So across from the 30 degree, whatever side value that is, let's say that it's x, then I'm going to follow this pattern where the side opposite from the 60 degree angle is going to be that same value of x but multiplied by the square root of 3. And then the hypotenuse is going to be the same value of x but multiplied by 2. So let me give you a real quick sort of easy example here that we could look at. Let's say that x has a value of 7. Well, then the side opposite from my 60 degree angle is going to be 7 times the square root of 3. And then my hypotenuse would be 2 times 7. So my hypotenuse would have a value of 14. So that's just giving you an example of what happens for each of the sides. And that's the pattern that we see, is that we have x times the square root of 3, and then 2x. 2x is always going to be the hypotenuse, since it would have the largest value. The hypotenuse is always the longest side. The other special right triangle that we work with is an isosceles right triangle. That's a 45, 45, 90 right triangle. So if I have an isosceles right triangle, that means my 2 legs are congruent, since the angles opposite are also congruent at 45 degrees. And then my hypotenuse is going to be the longest side. So let's say that I have some side length x. That's going to be congruent for both of the legs. And then my hypotenuse is going to be that same value but multiplied by the square root of 2. So again, let's try to do a quick, simple type example. Let's say that I have a leg where I have a side of, I don't know, let's say 3. So then the other leg will also be 3, since they're going to be congruent. And then my hypotenuse is just going to be 3 times the square root of 2. You could leave it in radical form, or you could plug that into your calculator to get the irrational value. And that's how this works. So now let me go back.